So, I am Evilmog. Apparently I know things and you're all here to see my lovely talk. You're here to see an expert. You're probably sorely mistaken, but that's alright. So we're here to talk about esoteric Hashcat attacks. So, we'll start with some of the... Come on, click. There we go. So, I'm Evilmog. I'm the Bishop of the Church of Wi-Fi version 3 or any greater version. I'm a member of Team Hashcat. I apparently consult for X-Force Red and hence all the pretty branding. I have a bunch of certifications. Somehow I got my OSCE. I have no idea how. I apparently do pyrotechnics for fun while we're at it. I'm a network monkey, server monkey, pentest monkey, doer-ish stuff. I'm the chief shenanigan officer for Derbycon, which is not a real title, so I'm not a real Derbycon volunteer. Do research, yada yada, all this stupid stuff. This disclaimer, I have to read this one out because IBM Legal will kill me if not. So, I am not a lawyer. Opinions expressed in this talk have not been vetted by IBM or any of its subsidiary companies. Views and opinions expressed are mine and mine alone. I'm not representing the Church of Wi-Fi, nor am I representing Team Hashcat in this talk. No warranties expressed or implied. Consult a professional. I'm not responsible if you set your house on fire, spike your electric bill, or otherwise break stuff. Practice techniques shown on systems you control and are authorized to penetration test, and don't steal dumps illegally. With that said, why the hell are we here? So some of us have more horsepower than brains, and we work with really fast hashes. So we do stuff like NTLM, MD4, MD5, SHA-1, SHA-256, Landman, SCP code, all the stuff where you get like 320 billion keys per second, and you run out of, when you hit that 90% mark, you need to find new attacks to get beyond 90%. So I like to get creative. This talk is all about the YOLO, so much YOLO. So I'm going to assume you all know how to use attack mode 0, which is straight wordless attack, mode 1 combinators. I assume you know how to use mask attacks, hybrid attack mode 6, mode 7. This is not a Hashcat 101 talk, and I also assume you're using Linux. I don't discriminate against Windows, but most of us use Linux or Mac when you're cracking hashes. So, we're going to talk about the infinite monkey theory of password cracking. So, infinite monkeys at infinite keyboards will eventually type your password. Unfortunately, we don't have infinite monkeys or infinite keyboards unless you're RenderMan back there. But we do have GPUs and fast hashes, which is good enough. So the trick to keeping a large cluster happy is throwing shit against a wall and seeing what sticks. Try random things. The nice part is Hashcat is fully pipelinable, so you can do really weird stuff with it. So, Raking. This is a technique that has been around for the last 5-6 years. It's how generated 2.rule was created, but no one documented how raking works. So we got some example code here, and by the way, all this stuff is on my GitHub, so you can go download all this at the end of it. But we're going to walk through this example. So what raking you do is you say start a sequence of 1 to 100. So you loop over this Hashcat attack, and you go and you set up, say, workload profile 3, so you're going to run really fast. Don't run this on your home theater PC. We're going to use attack mode NTLM, and where you do it on the straight wordless attack, tell it what your hash list is, and loop over all of your dictionaries. And I mean all of them. So grab 30, 40 dictionaries, throw it in a rule or throw it in a directory, generate 100,000 rules. And then we're going to turn on debug mode. What debug mode does is it will capture the original rule, it will capture the original word, the rule you cracked on, and then the resulting output. And we're going to collect all of these. You're going to loop it over 100 times. We're then going to run cut. We're going to create a debug.rule file, a debug.dict file, and then re-execute that attack. This is exactly how generated 2.rule was created because we sat there looping over all of our hash lists for 6 months. This is back in 2012. So this is basic raking. It hasn't shown up in anyone's hash techniques list. It's talked about on IRC once in a while. It's a really effective technique, and it should be done by more folks. I'm hoping someone creates a better generated 2.rule file, because mine kind of sucked and was created 6 years ago. So, next technique we're going to talk about, if we get really bored, is cut B. So this is someone dropped a blog, Rants by Chort, back in 2012. We've simplified his technique a little bit because his original script didn't really work 100%, so you need some tweaking to it. So what we're doing is we set a couple of paths. We then loop over a sequence. So what password splicing is say you have the password of 123 password. We will take number 1, we'll take 1, 2, we'll take 1, 2, 3, 1, 2, 3 PA, loop all the way through. That's a traditional cut B attack. So what this does is you can say you've got a giant Hashcat pot file, about 2, 3 megs, and you were trying to go set up an expander attack. When you're using a cut B style attack, you can do some interesting brute force by taking existing patterns on things, like say you have 2018 in a password, it'll get auto appended for you. Now this technique works fairly well, not many people do it, and you can process all your word lists. But we're going to show an advanced technique I created later on that's an enhancement to cut B that will decimate your password hashes. So that's cut B. Who here knows what expander is by a show of hands throughout the room? Probably everybody, right? How many people here modify expander? Because expander by default only gives you a 4-character output when you run your passwords through. So say you take your dump, you're going to get maximum 8 characters on an A1 attack. Every time you download Hashcat utilities, go open up the expander.c file, change length max from 4 to 8, then recompile the code. You will get far better results. But we leave this as a default because Adam one day decided it was more efficient to go with 4, not 8, but it gets terrible coverage. Little known trick, something that should be done by almost everybody. Add this to your tickle trunk. Now, this is the Evilmog secret sauce that tends to get me passwords correct left, right, and center. I call this my blender. So, what we're going to do is we're going to take your Hashcat pot file. We are going to cut using the colon for a delimiter. And now a secret we've got on this is a lot of people will stop your cut at the first colon. The problem is if someone has a colon in their password, you're not going to get the rest of the passwords, so your cracks are going to be incomplete. So you go -F2-, take the pot file, put it into a can.list. We run a standard cut B on it, forward and back, and then if you want to go really fancy, we run expander through it. So we take the output of your cut B, re-expand it, and attach. You'll get a lot of crap, and it takes your word list from, let's call it 4 megs, and it increases it to about 200 megs. But when you've got 8 GTX 1080s, it still only takes 9 minutes. And you crack another 10-20% on your password dump. Works fairly well. We're going to actually make this even better on the next couple of slides. But stuff like this is also in the GitHub, so it works fairly well. So our next technique, Purple Rain. Somebody modified Raking to make my life really easy. So basically what Raking is, you take a word list and you shuffle it. And the reason why you shuffle it is Adam wrote a tool called the Prince Processor, and it's basically a candidate password generator. The thing with Prince is if you give it the same output in the same order, you'll get the same results out of it. But if you shuffle the word list, it generates completely different candidates. So you shuffle, say, rocku.txt, you pipe it into Prince Processor, you pipe it into Hashcat, generate 100,000 rules and turn on debug mode, and you'll sit there and let it literally sit there for 3 days or so, and you'll crack a ridiculous amount of hashes. Just burn the horsepower. It's stuff you try when you have nothing else to do. And if you want to go collect the hashes afterwards, we call it Purple Rain Barrel. And this was revolutionary because if you do this on an NTLM version 2 hash, you'll probably crack it in the user world. Now, the other thing is, I was talking about how Hashcat is pipelinable. So, and all the Hashcat utilities are fully pipelinable. So we can do things like take permute, pipe it into prepare, pipe it into Prince Processor. So Jeremy got liquored one day for his class and figured, why don't we pipe the output of Prince Processor into Prince Processor, then pipe it into Hashcat, and we call it Princeception. And oddly enough, this actually works. So this example we have on here is we're going to shuffle rocku.txt. We're going to pipe it into Prince Processor, pipe it into Prince Processor, pipe it into Hashcat, generate 100,000 rules, and just let it sit there. Check on it in about a week. If you take this on your average corporate Active Directory dump, you'll go from, let's call it 40% hash crack to about 80 overnight. This also works well on NTLM version 2. I don't recommend doing this on a slow hash. Try this on bcrypt. You'll be very, very, very sorry. Do this on NTLM, SHA-1, MD5, MD4, anything reasonably fast. Even NTLM version 1 or version 2, it should be okay. Just don't try anything like that's salted and slow, because, yeah, you'll probably spike your electric bill. So that's Princeception. So let's kick this up yet another notch. How about we take cut B output, feed it into Print's processor with 100,000 rules, see what happens. Because why not? So we don't need this bash script because it really doesn't do anything, but I just get lazy on my pipelines and don't feel like shuffling members of my shuffle commands. So all we're doing is we're basically shuffling our can.cutb file we created earlier, pipe it to Print's processor, pipe it into Hashcat, generate rules, give it a pot file path, give it your usernames if you've got your things formatted the incorrect way, and away you go. So this one gets even more creative. Now, mask generation. Who here creates masks in all their candidate files? Probably not many of you. So tool came out aeons ago called Pack. The newest version on GitHub works fairly well. What we effectively do is you feed a bunch of word lists or your candidate files and you create masks based on them. So this is a basic mask generation, but the problem is you need to figure out how many packets per second you're running, have things finish in a reasonable period of time. So with my methodology, I set, say, 160 billion keys per second with a 360 second runtime for my maximum mask time. And I run this over not just my candidate.list, I run it through my expanded versions and my cut-b versions. So if you run it just off the passage you cracked, you're not going to get much. But if you run it through Expander, all of a sudden you're expanding your key space without resorting to straight out brute force. So run it over your expanded files or your cut-b files. So that, it works not bad, but what about hybrid mode? Who here still uses mode 6 and mode 7? If you don't, you probably should. So what do you do to figure out what people are appending their passwords with? Well, let's set the minimum length of 3, maximum length of 8, and redo that same style of an attack. Then use those in mode A6, A7. Don't just run it on your passwords, run it on your expanded, and it gets you some really interesting patterns. These will take you a week or two to run, but hey, you guys run your corporate Active Directory audits once every quarter or so. You can let it sit there for a couple of months for grins. God knows the attackers are. I mean, I collect my Active Directory hashes for years, and we go crack them later whenever I think of random stuff to try at 3 in the morning because I got no life. So, here's a typical A6 attack. We run Hashcat in mode 1000, so NTLM. Run it through your combined.ntlm file, which is our hash file in this case. Workload profile 3, mode A6. On the left side is my candidate.cutb file that I created earlier. Right side's my hybrid sorted mask I just created from that script. Turn on optimized mode and put on a box. The nice part is if you have 50, 60 nodes with multiple GPUs on them each, take a spare node, take it off in the corner, let it crack something, forget about it. It's like a good fine wine. Check on it in a couple of months, see what comes out. And here's some of the passwords we're getting out of this thing. It's actually rather creative. You got things like Unicorn 2016, MAAB 2018, Luke 2239. You got some weird stuff on here, and this was from an actual thing we extracted from hashes.org or some other legal repository of hashes. And this is all using these techniques in this slide. So I invented a new cut-b technique, and I'm rather proud of this because I was trying to fill content for this talk. Ran out of time or ran out of content, and I'm like, hey, everyone who does cut-b doesn't handle things in a very particular way. So we'll go back to the example of 123 password. If you're running a password splice on this, you'll start off with 1, 1, 2, 1, 2, 3, 1, 2, 3 PA, etc. When I'm done this, what we do is we stop at that, we increment the sequence, and then we go with 2, 2, 3, 2, 3 PA, and expand your pattern components. I figured out this only expands our Hashcat files for cut-b by 30-40%, but it was cracking that many more passwords and only taking still 9 minutes on a rig. So this is actually incredibly effective, and as far as I can tell from all my Googling, no one knows or no one's documented how this actually works. Sorry about that. So the starting of the script, it's relatively easy. We do a cut file. We do cut-d, which sets, here's our sequence number, or our delimiter of a colon. We rip apart the Hashcat file, pipe it out through a candidate.list. We start off a quick little loop through 1 through 8. You can modify this if you want to go with 1 through 9, 1 through 10 for your sequencing. Then a little bit of bash magic basically allows us to do negatives or increment this in a loop. So what this does is it restarts the sequence. So it goes 1 through 8, then starts 2 through 8, etc., all the way through. So it'll loop through and expand your candidate pieces. I haven't figured out how to make the negative side work yet, so I'm working on that piece. That update should hit Hashcat when I get liquored at the bar here at Derbycon, probably in a couple hours. So watch out for my GitHub. We then cat all the files together, run them through Expander, and create your files. So this one's relatively effective. And then if you really want to go hardcore, run Expander after it all and re-expand all your outputs, just because why not? And if you really want to get bored, take Expander and pipe the output of Expander into Expander. Just try stuff like that. I mean, I get up one day and I'm like, hey, I want to go pipe Expander in through permute, in through prepare, in through sort unique, then back into Prince processor and into Hashcat after piping it through shuffle a couple of times. Just try random things. The weird part is we don't want to resort to brute force, but sometimes you just get you'll get a writer's block almost when you're trying to crack a hash and you're trying to figure out what's cracking this, and entropy is your friend. Get out of that mold, try something random. I mean, I've done some weird stuff like piping music lyrics in through Expander, in through cut B, in through rule files, and then re-cutting them up with cut B and Expander again, then piping to Prince processor. Just go do random stuff. That's the point. These techniques are going to change all day long, but users, even though they are reasonably predictable, they do some random things like looking around. So if you can kind of predict how users are creating their passwords, you'll get far more effective. So that's what this whole kind of talk came down to. And here's a comparison of the file sizes, right? Like our standard candidate file started off at 2.6 megs. The expanded version are 189 megs. And 189 megs on an NTLM A1 attack, and that still takes, like I said, 9 minutes on 8 GPUs. If you're running this at home, less than an hour. And you get far more results. So try some of these techniques in the future for your next one. And now the best part is, while I'm at it, all this stuff is on GitHub. So feel free to rip apart the shell scripts, send me pull requests, play with stuff. My code of conduct is simple. If your code's good, it's good. Don't be a jerk on the mailing list if there is one, because there isn't. And hit me up on Twitter, and feel free to join the Church of Wi-Fi and watch our shenanigans at Hacker Jeopardy later on tonight. Questions now that I'm done. Thank you, by the way. Thank you all for showing up and listening to my rant. So, questions? No? Perfect. You guys all rock.